So let us go ahead and let us examine this particular wave over here. This can be seen on imanim.szialab.org. Here, if you notice, you can view the attenuation effects, which is weakening of the signals based on material. So you can see how the signal may become weak. Now let's first and foremost see, you can either compare two of these waves or you can use a single wave, okay? Enamin will animate electromagnetic waves in vacuum as well as other types of matter. Let us see how we can go ahead and we can do that. So you can see right now there is wave number 1. Okay. And here in the case of wave number 1, we can first and foremost set the wave, wavelength and the wave amplitude. We can in fact set it up either horizontal or vertical. Vertical looks more familiar. You can see you can have the amplitude as well as the wavelengths over here. And the moment you will go ahead and you will add material, okay, in the middle, you can now begin to go ahead and understand the effect. So here you can see the length is 16. Okay, let us set the extinction coefficient to, say, for example, 0.25. And can you see, while the extension coefficient as well as the refraction index will define how dense the material may be. So if there is no density, you can see it is passing through. But the moment I increase, can you see the effect and the weakening of the signal, which is causing this to have a different amplitude from the receiver and as compared to the original transmitter? You can see the amplitude is very, very less. Okay. In fact, if you go ahead and if you add a refraction index here, so let me go ahead and let me add a refraction index of say 1. And if I have continued to have further refraction index, you can see that there is a possibility that the structure of what is received at the receiver's end may differ significantly. All right. The more the extension, can you see now the wave is almost flat, which means there is nothing. Maybe there is a chance that nothing can be actually gone ahead and received. So you need to be careful with how you go ahead and you identify these. In fact, you can actually go ahead and you can use, I'm going to remove the material, but what if we have two waves? Let me keep both of them vertical. So right now, both of them are overlapping. If I add one wave with the other, can you see the final wave is dark blue in color, but can you see it is more peaked? Okay. So what this reflects is, if I have, due to extinction, due to refraction with material, okay, the very fact that I have material, can you see, even though my signal is reducing in strength at the receiver end, I am still receiving a higher amplitude signal than before. Okay, so amplifying the signal by superimposing another wave on top of it does make a difference. All right, because now the receiver is able to get a stronger signal than what it would. If I would have removed this wave, can you see how flat it is? With the addition of an extra wave, can you see it is more peaked? Can you see much more peaked? All right, so the addition of the second wave is still making the signal strong enough. All right, still making the signal strong enough so that you can receive it appropriately. All right.